Unit 3.2 notes. We're going to mainly talk about physical and chemical properties and changes and kind of understanding how to identify the differences. So let's get into it. Physical properties are things that you can observe or see or taste or smell or hear using one of your senses, and you can observe it without changing its identity. A physical property would be something like the color of an object, the smell of an object. Chemical properties, you can only see them when the identity changes, so when the substance changes. For example, flammability. So you only know how easy it is to catch something on fire if it's on fire and that's changing what it is. It's no longer going to be the same thing. In other words, if I have a piece of paper, paper is flammable, but the only way to know that for sure is to burn it. When you burn it, it's no longer paper anymore. So that's considered a chemical property. And look at the bottom here. To remember it, chemical starts with CH. Change starts with CH. So chemical change. It has to change if it's a chemical property. If it's something you can just observe and see it or taste it or smell it, it's a physical property. Go ahead, press pause while you put this in your notes. So here are, again, kind of what we said on the page before, but a little more detailed. Again, physical properties are observed without changing because change, CH, chemical, that would be the chemical. Physical properties don't have to change, and one of your five senses can see these things. You can feel it, the mass, the volume, the texture, how it feels. You can see its size, shape, the color. You can hear the sound it's making. You can smell it sometimes. You probably should not taste things in chemistry, but there are things you could taste like salt, things like that. These are all examples of physical properties because you can observe them without changing what the thing you're looking at is. Here's some fancier ones that we're going to be familiar with, especially when we move on to the periodic table. We've already said color and odor, but here's some new vocab for you. Luster. Luster is how shiny a substance is, and you can see it by looking at it. Certain metals have high luster, some don't. Malleability. Malleable means that you can take the substance and beat it into thin sheets, make it flat. And some things aren't malleable, but the point is you can hit the object, and whether it breaks into 2 or 3 or just turns into a sheet, it's still the same substance, so it's a physical property. Ductile or ductility is when you can pull a substance really thin, like into wires. Again, some metals like gold and copper have high ductility, some don't, but whether you pull it and it stretches or it breaks, it's still the same substance, so it's a physical property. A couple more that some you're familiar with. Conductivity, how it lets electricity go through it. Again, you'll learn eventually metals are very conductive or have good conductivity, but you don't need to change the metal to see if it conducts or not. Hardness, how easily a substance can be scratched. Diamonds are the hardest material, but you don't, even if it is scratched, it's still the same substance, so you're not changing anything. Melting point is the temperature at which a solid turns to a liquid. You should know freezing point is when liquids turn to solid. Boiling point is when liquids turn to gas, but it's still the same formula. Water, ice, and steam are all H2O. Density is one physical property we're going to investigate thoroughly. It's the amount of matter in a given volume. So if you have the same shape of an object, the heavier one would be the more dense, but we're going to do a couple labs on this, so you'll get it very easily eventually. You can pause this and read over it, but it summarizes some of the ones we've said. We won't do science song breaks in the makeup notes, get you done quicker. Properties can change. Matter's always changing. Ice in your soda melts, glass breaks, paper's ripped. But as long as it's still the same substance, the same formula, it's still a physical property. Like we said, water and ice are both H2O, so it's still the same substance chemically, and that makes it a physical property. Go ahead and press pause while you get all these vocab words down. Chemical property. The most common word you're going to see is reactive or reactivity. Does it react to oxygen? Does it react to air? Does it react to water? Chemical properties aren't that easy to see, observe, because again, the substance has to change. So if it reacts, that's a key word that lets you know. And here are some Physical versus chemical properties, you might want to look over. One thing to mention here is if you see bubbles, you mix two things and there's bubbles, that's an example of gas being made, and that's going to be a chemical property. We'll learn more about that later in this note, but just be aware now. Again, you're going to have makeup work, so we're going to skip through these. Actually, maybe you should not. Press pause after I explain how to do this and kind of identify each of these as physical or chemical properties. And then I'll tell you in a second. So pause it now, answer it in your head, and then I'll go over it. All right, density, we said is physical. You don't have to change it. Burning, well, that's changing, so that's chemical. Boiling is physical. It's still H2O if it's steam or water. If you see that it's green and soft, you don't have to change it, so that's physical. Melting is also physical. And react is one of those keywords that we said is chemical. So again, if you don't know by now, we're going to just kind of sum it up, the big picture. Physical change and chemical changes really tie in nicely with the properties we just went over. So a physical change is when the chemical formula stays the same, but a physical property changes. We already went over some, like melting. If I have a piece of paper and I cut it in half, well, so what? I have two pieces of paper, but it's still the same chemical formula. It's still paper. So those are changes. Water is different from ice, but not chemically. So that's it's a physical change. And two pieces of paper is obviously different from one, but it's still paper, so it's a physical change. Chemical changes are when we make new substances. We burn stuff, we cook food. Chemical actual changes occur that change the formula or what the substance is. This hopefully will summarize some of that for you.
Welcome to Moo Moo Math and Science. In this video, I'd like to talk about physical and chemical changes. Physical changes are changes in appearance only. A new substance is not created, and chemical bonds are not formed or broken. For example, take this stack of paper and wadding it up into smaller pieces is a physical change. It still has the same properties as the original paper. Cutting someone's hair is a physical change because the hair has the same properties as the original hair. Phase changes are physical changes. When ice goes from a solid to a liquid to a gas and then back, those are physical changes. Most mixtures are physical changes. For example, mixing salt and water together is a physical change because the salt and water can be separated out later. Chemical changes, on the other hand, create a new substance. It involves breaking or making chemical bonds between atoms. Chemical changes leave behind clues or indicators. Here are 5 indicators of a chemical change. First, if you see burning or fire, you have a chemical change. Second, a temperature change without heating or cooling is an indicator of a chemical change. Third, an explosion is an indicator of a chemical change, and they're pretty fun. A change in color is a chemical change. A change in odor can be a clue that a chemical change has occurred. And anytime when you mix items and you see bubbles or it fizzes, you have a chemical change. Thanks for welcome to Moo Moo.
All right, so kind of summarizing what we've said and they've said, if a change happens that doesn't change the identity of the matter, in other words, it's still whatever the chemical formula is. Like, again, water is the easiest one. We all know water is H2O, and whether it's liquid water, ice, or steam, it's still H2O. So those changes, phase changes, they're called, going from solid to liquid, liquid to gas, are always going to be physical. because it's still the same thing. Might want to press pause and read some of the common examples down there. Anytime it's still the same substance, it's going to be a physical change. And we'll practice plenty. Chemical changes do change what it is. So you have an entirely new substance. Things like rusting, iron. It's not iron anymore. It's a new substance. Iron oxide, it's called. Wood burning. It's not wood anymore. Copper, when it changes to brass, well, it went from one thing to another, so it's new. Baking a cake changes its chemical composition. Spoiled milk, you can smell it, like the video said. That's a change in odor. So all those changes, CH for chemical, CH for change. The only way you can see a chemical property is by changing what the substance is, which makes it more difficult. A piece of paper burns and it turns to a black substance. After the flame goes out, you can no longer burn that new substance. It's gone, it's a new substance. The chemical properties have changed. Milk needs to be in the fridge or it goes bad. If you've ever seen or smelled spoiled milk, it's not pretty and it stinks because it's got a new substance in it. Physical changes, you can kind of reverse some of them. If I cut a piece of paper in half, I could tape it back together. But chemical changes cannot be reversed. You cannot make sour milk good again. You cannot turn burnt wood back into wood. I want to press pause and look at some of these. Common errors, the phase changes, ice melting, water freezing, water evaporation. People sometimes think that it's changed what it is, but it hasn't. Still H2O, so those are going to be physical. And dilution, we haven't talked about it, but it means like pouring maybe water into a solution to make it less strong. Well, that substance is still in there, and you could burn off the water and leave what was ever in there. So really, that's just a mixture, so it is a physical change. Go ahead and press pause while you put this in your notes. You might want to pause and answer these as chemical or physical changes. Pause now, and then I'll give the answers. All right, if you bend aluminum, it's still aluminum, so that's going to be physical. When you paint a wall, you can take paint off, so the paint's still there, the wall's still there, physical. Remember, anytime we cook something or burn something, we've made something new, so those are both chemical changes. If you break a desk in half, it's still a desk, so that's going to be physical, and burning again is chemical. And you should be good.